mother's with the child at the park while the police is on duty. Once the police left to get her cupcakes, a kidnapper stole the mother's baby.
The kidnapper took the baby north at 15 miles an hour
Because he has to drive safe with the baby in the car.
and the police officer was traveling 5 miles an hour to get her cupcakes when she got the Amber Alert call.
5 minutes later, what will the rate of change be for the police to save the baby?
Get my phone.
Hey, what's your name? You want some candy?
No, I'm okay.
Too bad, I'm gonna take you anyway.
No! Mom, help! Help, Mom! Mom!
Sharkeisha! Sharkeisha! Sharkeisha!
Cupcakes are so good. Hello? Yes. Dispatcher 1738. Is that an Amber Alert? You say? Okay, I'm on my way.
Okay, so here at point A is the park. The kidnapper stole the baby and is going north 15 miles per hour. We're going to call this Y. While the police officer is going to get her cupcakes at 5 miles per hour. This is going to be called X. So the rate of the Y axis is 15 miles per hour, and for the X will be 5 miles per hour. What we're trying to find is the distance from the officer to the kidnapper. What's going to be the rate? And we're going to call this Z. So dz over dt equals what?
Okay, so it's been 5 minutes since Sharkeisha was taken. So what we're going to do is we are going to convert to hours. So I have 5 minutes. There are 60 minutes in one hour. So I'm going to multiply, and that goes to 5 over 60 minutes, which is equivalent to 1 over 12 hours. So what we're going to do is we're going to find our X, and our X is actually our police officer. And we're going to get our amount of time, which was 1 over 12. And we're going to multiply that by our dx dt, which was 5 miles per hour. We're going to multiply that, and that goes to be 5 over 12 miles. So that's our X, and now we're going to go ahead and find our Y, which is our robber or our kidnapper. Okay, and we're going to do the same thing. So we're going to get our amount of time, which is 1 over 12 hours, and we're going to multiply that by our dy over dt, which is 15 miles per hour. So I made that kind of small. And we're going to multiply that, and that's going to be equivalent to 5 over 4 miles. So now what we're going to do is we're going to go ahead and do our Pythagorean theorem, just like we do our triangle before. And we have our y over here, our x over here, and our z right here. So this was 5 over 12, and this was 5 over 4. So now what we're going to go ahead and do is we're going to be doing our x squared plus y squared is equal to our z squared. So now we're going to go ahead and plug in. So it's going to be 5 over 12 squared plus our 5 over 4 squared, which is going to be equal to our z squared. So what we're going to do is we're going to solve for our z. So we're going to do this. We're going to do this. Crosses out that. Crosses out. Yes. Yes. And then that's going to go ahead and be equal to 25 over 144 plus 25 over 16, which is equal to our z, which is going to be also 125 over 72, which is equivalent, or an approximation, to be 1.3176 miles. And that is our z.
So you're going to start off with the equation x squared plus y squared equals z squared, and you're going to find the derivative of that. So that's 2x dx over dt plus 2y dy over dt equals z d 2z dz over dt. And then you divide by 2, or well, the 2's cancel each other out. They reduce. And you're left with x dx over dt plus y dy over dt z dz over dt equals. And so then you plug in the numbers that you have for those. For x, for dx over dt is 5, y is 5 over 4 and 15, and z equals 125 over 72 times dz over dt, because dz over dt is what you're looking for. Okay, so if you simplify, you get 25 over 12, if you multiply and simplify, plus 75 over 4, over 125 over 72 equals dz over dt. What happens is you divide this over. These cancel out and you end up with this. So if you plug that into the calculator, you end up with 125 over 6 divided by 125 over 72 square root equals 16.1374 miles per hour.